this is Jiantao Zhangh, and this is the final report of my project for image processing. The title of my project is Road Extraction using colorful map based on image segmentation. What is the meaning of colorful maps? I mean, just like this Google map here. This is the colorful map in this project. And here's the introductions of my project. It says that extracting information, especially road information from a map, is very important, and that is a major part of this project. So why is this road extraction so important? Now assume that you have an image of colorful map here, just like this Google map, and you do want to recognize every road on this map by your own eyes. What you want to do is tell the computer, here, hey, I got some code for you, and I need you to find out all the roads on this map. Mark the road to be white and all the other things to be black. I just want to see roads and nothing else. Okay, just like this picture, here is the output of my project. And this is what the result I want to get. And these are all the reasons we work on the road extraction. Now come back here. I have found some related works on this topic. They all worked on satellite maps. Here is one using level side and mean shift methods. And here is another one using unsharp mask algorithm to find out the skeleton of the roads on this satellite map. But now we are going to deal with this colorful Google map. Why it is difficult? Here I got some problems I need to fix up. The problems are here. See, we got names and tags we cover on road. We got no clear age for each portion, and buildings, rivers, ground, exactly what everything need to be identified on this map. We can see that here are some names covered on road, covered on building, and covered on ground. These names are very annoying. We need to fix them up. We need to remove them, and we need to keep the road to be completed. And here's the result I got after this project. This is the output of my final result. So I designed a few steps for this project. The first step is separate each part away from others by its color. What do I mean? As we can see here, each part in this map, like buildings, roads, and anything else, they all have their own color, and different color are used for different region. Like this road is all in white and yellow, and the river is blue, and this is a very important feature we got on colorful maps like this map. So we need to use these colorful features to identify each part of this map on this map all by their colors. Okay, come back here. We can see here I found four areas blocks, 2 road blocks, and 1 river blocks here. What do I mean by this feature, by this RGB blocks? I see this is the pure colorful blocks. In this map we can see that roads are all white or yellow, and ground is green, and this is the buildings. They all have their own color, and they will not change. The same color means the same things on the map. So we just find some standard color blocks for each region. Like here, the 4 blocks are for areas. The area means buildings, grounds, anything except roads. And we have 2 colors of roads. They are white and yellow. These 2 blocks means if the color of this pixel same to any of them, this pixel should belong to roads. And also we got some river blocks. River is blue, exactly. So for each block, I need to know what is the RGB value. So I need to calculate the average RGB value for every block here. For every block, I need to calculate its red, green, and blue value for everyone and separately. And after we calculate the average value, and then we need to calculate the D value for each pixel on this map. What is the D value pixel? For each pixel, here we got a D equation, and when we have a pixel, we have its RGB value. Here we put a value here, and the three values of RGB average value for each block, for each standard block, is different here. So we need to calculate the D value for each pixel, for every pixel on this map, and if the D value of this pixel for the standard block, I mean, if we, for example, here we got a pixel on this map, whatever, we got a pixel here, and we calculate, we want to know if this pixel is the root pixel. So we get the RGB value of this pixel and put them into the equation of D value. We get a calculation for this value. We put every standard block's average RGB value into this equation, and we calculate them separately. We find maybe I think it's seven D values for different blocks, and we compared each blocks with a given threshold value. If for example, we calculated this pixel, and we operate on this white rolled blocks. We find that the D value we got is smaller than the given threshold. So we may consider that this pixel should be defined to a road pixel, and this belongs to the road region. Okay. And if it doesn't belong to a road region, we should try another block and calculate the D value and compare the D value and the given threshold. If it doesn't fit to any block that we have, here we have 7 blocks. If this pixel doesn't belong to any of them, so we define this pixel to be a noise pixel and its color to be pure green. So we have some images of the outputs. Here, the first image, I operate on these 4 areas blocks, and we got output here. And also, after I operate on the river blocks, we can see here some river blocks. They are all blue, and we operate on the river blocks here, and we got output of here. The river are gone. And finally, we find the road blocks. We define all pixels belong to these 2 road blocks to be white, and we have the output here. And finally, for those pixels, they do not belong to roads, they do not belong to areas, and they do not belong to noise, and they do not belong to river. I define this pixel to be noise and their color to be green. Here. Okay. And here is the second step. After the procession we got above, we can see that there are many pixels wrongly defined for those pixels of road surrounded by area pixels, or area pixels surrounded by road pixels. They are considered to be wrongly defined. Pixels surrounded by noise or same pixels is readily defined. What is the meaning of this sentence? For example, we got a pixel here and we find its 8 neighborhood pixels. We find that the area pixels, for example, this pixel is the road pixel, and we find the area pixels around is much more than the road pixels around this pixel. So this pixel may belong to the area pixel, but not the road pixel. So we redefine this pixel to the area pixel. Similarly, if we have an area pixel here, and the pixels around it, and the road pixels around it the number of road pixels around it is much larger. So we redefine this area pixel to road pixels. Okay, here's the procedure we have, and now we got the output of this error tag procedure, this error tag function. The third step, we need to denoise. What is denoising? After these tag operations, there are only 3 parts on this image: road part, area part, and noise part. Most of these noise parts are names of roads and streets or terraces. So we can see here there are a lot of names here. They are all names. We need to remove this part, this noise pixels. So what I need to do here for denoising is classifying these noise pixels. Redefine pixels to be road if they cover on road, and other pixels to be area. So same like the AirTag, we also use the nearest neighborhood grouping method, and just we find 8 pixels around it. So here is the output of the noise. We can see here there are some broken rows. There are names before I do this denoising. I really just remove these names, these words on this map. And the first step, the morphology methods. Morphology methods are used here to make the output image much clearer and completely. It's a optimization method for this map. And I used IM dilate to expand the rows to make the broken part, connect the broken part to make it much more completely. And I use spur and clean to remove little spurs and make it to clean the whole image. And this is the final report, the final result I got for this image, for this colorful map. Here, we have some problems for this project, and so the problem is the first one, the threshold. Remember the threshold? The threshold for this equation, threshold here. We should define the threshold all by ourselves, so we need to find out the best threshold to to operate on this image. And for different image, they will have different thresholds. And then the second problem here is the AirTag method is important to make sure that each pixel is right in its region. And if we do not use the AirTag method, the names and text on this map will not be removed. Like this one. This is the output if we do not use the AirTag method. You can see the names here, they are not removed, they are all clearly here. However, the problem is it may also break these rows when we remove these words with AirTag method and denoising method. So I need some better algorithm in my future work, but not the nearest neighborhood grouping algorithm. What is the meaning? The final output here with the AirTag method, we can see there are some broken parts of the roads. And if we do not use the AirTag, we can see some names here, we can see some words here. It's very annoying. It's hard to choose. If we do not use AirTag, we got some names. If we use AirTag, we got some broken points. So in the future, I think I need some better algorithm. And this is a summary, is a conclusion. In this report, I designed several methods to extract road information from a colorful map step by step. The result we got is partially good, and it can prove that this extraction method is well worked on this city map image. However, there are still some difficult problems for me, and the city map is pretty complicated, and the roads are sometimes covered by its name on this map. So it's hard to find out a perfect algorithm to remove these words and keep those rows not broken. I designed the AirTag and denoising method operating with nearest neighborhood grouping method. They may remove these words, but they may break these rows at the same time. So I think I need a better algorithm. As I said, I need a better algorithm in the future. And thanks for your watching.